Okay, so I wanted to just touch back on some of these terms because if you did that assignment last Thursday, it's been almost a week. So I want to get those back in front of you, talk about them again. So you should have been able to tell the difference between observational study and experiment. Observational study, you're just watching what's happening. You're doing nothing to change behaviors. You're just watching what naturally occurs. Experiment, you're imposing a treatment. You are changing something about their behavior. You're assigning them to a specific treatment. Okay? Typically, in an experiment, you will see something about randomization. If randomization is happening, experiment. Most of the time, if there's no randomization, it's observational study. An observational study can be, I want you to track over the next week how many times you go to the gym. It could be how many times last week did you go to the gym. So it could be about future behavior or past behavior. You're just observing what these people naturally do. Okay? Here you're assigning them a treatment. You're saying this group, you're going to do this activity, this group, you're going to do this activity, we're going to see who gets the best results. Okay? So that's going to be our difference between those. Then we talked about some variables. Explanatory variable, response variable. Explanatory variable is what explains the difference in the results. So it's what variable did we change? What is the difference between the groups? That's our explanatory variable. So this is the X variable. So it's what are we hoping will make a difference? What are we testing? Okay. The response variable is what are we measuring? Okay, so what is measured at the end to see if the results are good or bad or whatever? We want to know what are we making a difference in? Are we hoping to reduce cholesterol level? Are we hoping to get a healthier weight? Are we hoping to, whatever it is, we're hoping to measure and find the difference. That's our response variable. Okay? So what we think is causing the difference, what explains the difference, is our explanatory. What we're measuring is response. Okay? Questions so far? You guys remember this from last week? Hopefully. Okay, good. Good. Experimental units. This is what is receiving the treatment. Okay? So, if we're talking about trying out different types of fertilizer on plants, the plants are the experimental units. If we're talking about, if you remember, let me think of one that we did. We could be talking about having different people try different exercise programs. This group of students are going to do cardio workouts. This group is going to do weightlifting exercises. So we want to see which one gets the best blood pressure after 6 months or something. The experimental units are the students that are doing the exercise. Okay? So it's who is the treatment applied to. The factors are what are the things that are being tested. So sometimes there's one factor, sometimes there's more than one. In our exercise program, that's the only difference between the groups is which type of exercise we assign. There's one factor. Okay? If you look at the example you had in that online assignment about the baking cookies, we looked at different oven temperatures and we looked at different cooking times. So there were two factors. We changed temperature, we changed cooking time. So two different things were being changed. So two factors. Sometimes we'll have multiple factors. The levels are how many different ways did we try each factor. So if we were talking about the exercise program, there was just cardio and weightlifting. If we're talking about like baking cookies, there were 3 different temperatures for the oven. There were 3 different cooking times. So each factor has 3 levels. So when you combine those, you get the treatments. So it's all the different ways you can combine all the factors and levels. So typically, to get how many treatments, you take, if there are multiple factors, you take how many levels for this factor and multiply it by how many levels for this factor. And if there's a third, how many levels for that one. So you just multiply all those together will tell you how many treatments. So a question that's pretty typical is they may give you this is the explanation of this experiment we're going to do. Tell me, what are the factors being tested? What are the levels for each factor? And they could ask how many treatments are involved. List the treatments that are involved. So you would just list out all of the different ones. We bake the cookies at 325 for 8 minutes, 325 for 15 minutes. We bake them at 350 for 8 minutes, 350 for 15. You would list out all of the different things that you could combine, and those are the treatments. Okay. So that's kind of the type of question you'll see with this. It may ask you, is this an observational study or an experiment, and how did you know that? So you have to justify, why did you know that it was an experiment, not an observational study? And you would say something about, because the treatments were randomly assigned. The patients were randomly assigned which medication they were going to take. That makes it an experiment. Or we were just asking about their workout behavior over the past week, so that's observational study because we did not assign them to a workout procedure. So there has to be justification. You don't just say it's this and stop. You have to justify why you chose what you chose. Questions on any of that? Just kind of a quick tour through. All right. On page 28 is where you're going to put problem set 5 if you haven't already done so. What I want you to do is read through those. It's just two different scenarios. You're going to decide, is this an experiment or an observational study? So read through those, discuss in your groups if you want, and then we'll talk about it in a couple minutes. Okay, let me pass that. Observational study. Why?
Because they recorded how they did on the test based on what their blood pressure was.
Right. It was all based on what they already had as a blood pressure. Okay? So nothing was randomly assigned. They didn't do any of that. So observational study. Good. What about the second one? Good. Experiment. Why is this one an experiment? I'm sorry. Right. They applied a treatment. They randomly assigned them to one of the treatment groups. So that makes it an experiment. Good. Good, good. Okay. So are we seeing the difference? Hopefully. Good. Okay, so we're going to look at this note-taking guide for today. So we're going to start up here with principles for designing experiments. There are certain things, when you design an experiment, you have to include certain things. That's what we're going to talk about here, the principles for designing experiments. Tomorrow we're going to look at the method of assigning, but today we're just going to look at some terminology, things you need to know, things that are required in an experiment. So principles for designing experiments. So first thing we're going to look at is control. And some of these you may have experienced in other classes. I know you've done other things with experiments, I'm sure. So a control. When we're setting up an experiment, we want to make the conditions between treatment groups as similar as possible. We want to make all the groups pretty much the same other than the treatment that's being applied. Okay, so you will hear me refer to a control group. Don't confuse these two things. A control group is part of the control in the experiment, but sometimes there's a difference. A control group is a group used as comparison. So typically they are just kind of what would happen if we didn't give them a treatment. Because sometimes just the fact that you're participating in an experiment can make certain changes to your behavior. For instance, if we're trying out different diets, okay? So we want to try out the keto diet versus the South Beach diet or whatever, and we want to see how these affect weight loss. Okay, so we have people wanting to lose weight, they're trying to do these different diets. We will have this other group that is our control group. We tell them, you don't have to do either one of those. Just continue eating as normal. We're just going to monitor and see what happens. Sometimes that group will change their behavior because they're now part of an experiment. They may eat differently. They may cut out some snacking or something because they're like, okay, I'm going to be weighed in a week, and I want to, they're aware of that. And so sometimes they will lose weight just because that's going on. It has nothing to do with being told how to eat. They just do things differently. They may exercise more. They may do other things that cause the weight loss, and that allows us to go, okay, how much of it was the keto diet and how much of it was just they were in experiments? Okay? So it allows us to see what would happen just if we monitor weight without doing anything versus monitoring weight while doing these certain diets. Okay? So that control group tells us, okay, this is what would happen if nothing were done. Now we can compare that to what's happening when we tried something. Okay? So that's the idea of a control group. Often you will be asked, how are controls used in this experiment? So you want to say, okay, we didn't put all the male subjects in this group, female in this group, and then try out a hair product. We want to see, is shampoo A better than shampoo B? Well, it might just be that shampoo A works better on men and shampoo B works better on women. So we're not getting a difference in the shampoo, we're getting a difference in how does it respond to men and women. So there's a problem. So a control would be we mixed men and women are in both groups. Okay? So that would be one of the controls is we made sure the groups had the same number of men and women in each group. So sometimes they will ask you, how is a control used in this experiment? The next thing, random assignment. This is something that has to be done every time. This was one of the things we look for to see is an experiment. So we randomly assign each experimental unit to a treatment group. This helps reduce bias. That's the whole point of randomization, is to reduce bias and equalize the effects of any unknown things that could go on. Notice there's a lot of vocab in AP Stat. Have you noticed this? There's a lot of vocabulary. There's a lot of terminology. One of the things you have to be really careful with is whenever you use this terminology, it has to be used correctly. You want to be careful about throwing out certain words and not using them in the correct way. They get really picky sometimes on the grading rubric about if you use words incorrectly. So that's Here's one of the things that seems really picky, but I wanted to let you know, this is in the grading rubric on several other questions that have shown up on the AP exam. You notice it says here, we randomly assign the experimental unit to a treatment group. That's the order it has to be assigned. We take the experimental units, they get assigned to the treatment, not the other way around. Some of the AP rubrics will say, if you say assign a treatment to the experimental unit, they count it wrong. So be careful. You're taking the experimental units, assigning them to the treatment group. Okay, it seems really picky, but if you get used to doing it in that way now, and you do it that way every time, it won't be something you really have to remember because that's just how you do it. And when we get into looking at the actual design in tomorrow's notes, you'll see that visually, and I hope that that makes more sense. But be careful of the way you word it. You assign units to the treatment. Okay. Next, replication. So we have two different types of replication, and I'll talk about each of those. I'll let you guys write, and then I'll talk about it. But we need to replicate our study using many subjects in order to estimate the variability of responses. We'll have replication in the study and replication of the study. Okay, so this idea of replication says you can't just have one person in each treatment group. Okay? You can't just say, well, I want to try out this shampoo with my family, so I'll have my husband use this shampoo and my daughter use this one, and then I'll see who has better food. Okay, well, each person may react slightly different, and so we need many subjects. We need a lot of people to try each one to see which one is better in general. So we want to use many subjects. So you need to have multiple subjects in each of the treatment groups. That is replication in the study. It's showing within the experiment we have multiple people receiving each treatment. Replication of the study, this is where the entire study could be repeated using the same procedure and should get similar results. Okay, so this is the idea of whenever you were doing the random number tables, and remember how you had to list all the different steps so that somebody else could follow exactly what you did and get the same things that you got using those numbers? It's writing it up in detail so that someone else could follow your procedure and they should get similar results. So that's replication of the study. Most of the time, the questions will deal with this, but you want to keep this one in mind because that's how detailed you need to be when you're writing it up. You need to make sure you include enough detail that somebody could follow your process. Okay, last one, comparison. A design, you always use some design that compares two or more treatments. You have to have something to compare to see our results. That goes back to the idea of that control group. If we are just testing one product and we want to know, does this help people, we need to compare it to a control group to see, okay, would people be better off even without it than they were with it? And so this happens. You have to have a comparison within the experiment. You have to have something to compare. So those are our 4 required elements: control, random assignment, replication, and comparison. Questions on any of those? Okay, we're going to move over to blinding. So what is blinding? Blinding is when a treatment is given and it's not revealed to either the subjects or the researcher which treatment is being given. So sometimes you can't blind things. Sometimes you just don't know. But sometimes you can. So often they will ask, could this be blinded? If they're saying, I want to do this test on whether drug A or drug B is better at helping control cholesterol levels. Okay? Would it be possible to blind it? Well, we could just say, okay, you're getting this medication and just putting it in a bottle that's not labeled except with the patient's name. They get that. They don't know which one they're taking. So if the treatment is not revealed to the person taking it, but the person that's actually analyzing results, they would know which one they're getting. So you have to look at, could it be possible and could it not? So if we were looking at, do people recover from, let's say, a knee injury better with surgery or just with physical therapy? And we could look at those things. Obviously, the person would know if they had surgery or not. So that would not be blinded. So sometimes you can blind it, sometimes you can't. Sometimes you're going to know which treatment you got. So there are 2 different types. Single blind. This either the subjects or the researcher, one of the 2, doesn't know which treatment is being received. Researcher not know which one they're getting, because how will they know which one's better if they don't know which one they got? Remember, the researcher, when it says the researcher, that's the person collecting the data, not necessarily the person analyzing the data. Okay, see the difference? So if we're talking about, did this medication help with blood pressure? Okay, we may be testing 2 different medications, but we just labeled them A and B. The people don't know which one is which. Maybe we're testing generic versus name brand. They don't know if generic is A or if generic is B. No idea. The person getting it, they don't know if they're getting generic or name brand. The person measuring the blood pressure, they don't know which one they got. They're just saying, this patient, this is their blood pressure. This patient, this is their blood pressure. The person analyzing it that actually that actually does the results and publishes the study, they would know the difference. But the person collecting the data would not know. Okay? Does that make sense to you? So when we talk about this, don't confuse the researcher with the person publishing the study, because that's different. So this is the person interacting with the subjects, not necessarily the person who is called for the study. Okay, double blind. This is neither the subjects nor the researcher knows which treatment is being received. So neither of them know. Alright, let's look at placebos. So a placebo is just a fake treatment that looks just like the treatment being tested. Let's say we're testing a new anxiety medication where they wear a patch on their arm that delivers the medication through their skin. They may have one group receives that patch that has the medication. Another group gets the sticker on their arm, but there's no medication in it. They're receiving a placebo treatment. Okay? So they do that because of the placebo effect. The placebo effect is when someone who got the patch that didn't have any medication starts having less anxiety. So they have the desired result, but they didn't get the medication. Mind is very powerful. This placebo effect is totally real. It happens. People think just because they're in a study, they're getting a treatment, they're going to feel better. They're going to do more. They're going to do things. And it happens. That's why there's that comparison. We have to have someone to compare them to, because just being in a study will sometimes give them results. Okay? So you have to account for that as part of your experiment. Confounding variables. This is something we try to avoid as much as possible, but sometimes they happen. This is when two variables are associated in such a way that their effects on the response variable cannot be distinguished from one another. we do our best to set up controls in the experiment, to do our randomization, to do all of those things we talked about in that first part. We do our best to avoid these by setting up a good experiment. Okay? So let's say I wanted to know I want to judge how boring, we'll say, a movie is. So I'm going to show this movie on how paper was invented. Okay. And it's an hour and a half long. I'm going to show it to one group of students, we'll say at 7 a.m., and another group of students at 7 p.m. And I'm going to count how many times there were yawns in each group. And I'm going to see how people did with it. Well, the problem is, let's say I show that history, how paper was made at the 7 a.m. group. And at the 7 p.m. I go, okay, well maybe they're not into history. Maybe they would rather watch something on cooking. So I have, I don't know, some chef competition show that I'm going to show in the afternoon group. So I'm going to count the number of yawns, and I'm going to see which one is more boring, the history show or the cooking show. Well, what else could be affecting how many yawns I get? One's at 7 a.m., one's at 7 p.m. When are people usually more tired? 7 a.m. They may have just gotten up, they're so tired, they're like, I didn't get enough sleep last night. So that would be a confounding variable. Something other than the show they're watching is causing the yawning reaction. Okay? So that would be confounding. We would want to place controls to see. We want to show both films at the same time. Okay? So there are two different groups at 7 a.m., two different groups at 7 p.m. We want to know how do these compare at the same time. Okay? So we want to try our best to avoid confounding because we want the only difference between our two treatment groups is the treatment itself. Everything else is the same. Okay? So when you're asked a question on an AP exam or on a quiz or on a test, how are you expected to answer? First of all, you need to talk about how the variable that you think is a confounding variable, how that is associated with the explanatory variable, and then second, how is it associated with the response variable? Okay, so let's look at an example. So this is going to look at the old adage, an apple a day keeps the doctor away. And we're going to think of what else could be the explanation for why you didn't go to the doctor. Okay, so this is saying if you eat an apple every day, you're not going to get sick, you're not going to go to the doctor. So you have to think what else could be a part of this person's life that's eating an apple every day that could cause them to not go to the doctor. So what I thought is a person who eats an apple every day may also eat a healthier diet in general than a person who doesn't eat an apple every day. So if that's their habit to eat an apple every single day, they may eat a healthier diet in general. And so the healthier diet may be what keeps the doctor away. So you see this first sentence is dealing with the explanatory variable. This is what explains it. Is their healthier diet? That explains the difference. And then that says the second part is how it affects the response variable. That's what keeps the doctor away, or keeps them home. So you have to tie it to each variable. Next time we're going to look at how do we actually design the experiment. Now that we know all the things that should be a part of it, we're going to look at actually designing it. So, what I want you to do for your exit tickets, it should be in your folder. Tell me something you want me to know about you. Could be school related, doesn't have to be. It could be what you like to do in your spare time. It could be, who knows.